All right, you guys. So we're going to start at the very top of this page. I'm going to talk really fast through this because it should mostly be review for you. But when you're looking at a polar coordinate systems, which are used when you're the most famous, I think, type of example is if you're in a ship and you want to know how far away things are from you, it's easier to measure in concentric circles, distances away from the ship, than it is on a rectangular coordinate plane. So to form a polar coordinate system in a plane, you're going to fix a point on the origin, and we changed the name of the origin, and it's called the pole. So that's important to know on the AP test because sometimes they're asking you guys, what's the distance away from the pole? And the pole is the origin in the rectangular coordinate plane. So we'll call that coordinate point the pole, and it constructs an initial ray called a polar axis. So rather than having an X and Y axis, you guys have what we call a polar axis. And the polar axis in this case is this ray here, the initial ray. And you guys can equate it to the positive x-axis on a rectangular coordinate plane. So just the right side, the positive values of the x-axis. Okay, and the coordinate point when we plot it is our distance away from the pole. So this is a radius measure. And the angle measure tells you guys how far away from the polar axis you are, which is usually described as theta. So when I'm looking at a coordinate point, this point right here, we would write as r comma theta, radius first, angle after. So we can also fill that in here, r comma theta is how you would describe a coordinate point as opposed to x comma y. So when we're looking at plotting points, so on your battleship, as you guys are looking at filling in the points for your battleship, your ships can go, by the way, on the spokes of a wheel, meaning that it can go along here. For example, if your ship is 4 units long, you guys can go like 4 points like this. Just make sure that the points are in a row. I had some years where kids are arguing like, I swore I hit your ship, and then someone skips a point. And so that's a cause for frustration. You guys can go across the pole if you like so if you do 4 ships like that, that's fine. Just make sure they're consecutive points. Or you guys can go along the circle itself, like 4 in this direction. Okay, so look at the dimensions. I think it's like 4, 3, 2, and 2 or something like that. So, oh, and then there was a year I did battleship and I said, you had to name the exact coordinate point. Like, so people did stuff like 25 pi over 3, and then it took a really long time. So as long as you guys hit the coordinate point, the point itself, it doesn't matter if the way you named it is different because there's an infinite number of ways to name these coordinate points. So on A, we're going to plot 1 comma pi over 6. You do the angle first, and then you do the distance away from the pole is the radius. So pi over 6, 1. It would be, we would go pi over 6 and then go 1 out in a positive direction, which would give you guys that coordinate point, and then label that A. Can you guys go ahead and do B and C and just double check your work as you guys do it? So obviously with unit circle, we know we can do negative angle measures. Okay, the other thing that we might or might not remember is that with polar coordinates, not only can you guys have a negative angle, but you could also have a negative radius. And that puts you across 180 degrees across onto the other side of the ray. So for example, if I'm plotting D and I have pi over 2, well, pi over 2 is this, technically just this ray right here. So if the radius is negative, we're going to go opposite. So towards 3 pi over 2 in the opposite direction. And then this coordinate point right here would be considered negative 2 comma pi over 2. So right here would be D. So 180 degrees across in the opposite direction. So go ahead and plot E with pi over 4 negative 1. Puts you 180 degrees across from the first quadrant would be the third quadrant. So these things are important, just minor concepts that aren't directly tested on the AP test. You guys are only tested on AP concepts. but it's nice for us to have a good foundation. So moving beyond plotting points, we're gonna now just plot two curves given a really basic curve, and then we'll talk about more complicated curves when we get back. Example number 1, you're graphing something that has an equation r equals 2. So we think about what r represents. R represents graph something where all the coordinate points have a radius of 2. So we should be in our mind visualize what that would look like and quite easily picture that that's a circle. So we're gonna graph r equals 2 being the shape of the circle. If you guys notice, this equation is much simpler than if it was written in rectangular coordinate points with an x and a y. We have just a single variable, radius is equal to 2. And so that's the purpose of polar coordinates, is to describe situations in which a circular pattern is easier to describe than with polar coordinates than it is with rectangular coordinates. Okay, for example number 2, theta equals pi over 3. We might be tempted to say theta equals pi over 3 are all the points, infinite number, that go along this ray right here. What did I forget? If I say that theta, and this is common to make this mistake, that this is that theta equals pi over 3. What did I forget? Yeah, exactly. So those are theta equals pi over 3 with just positive radius measures. R can be negative, exactly. So we want to make sure we extend that into a line, not just a ray, into the opposite direction. Okay, very simple, basic stuff here. We'll get to more complicated stuff after the break for graphing. Okay, so the important part for the AP test, you guys have to memorize these relationships on how to convert between something that is polar to something that's rectangular, and then vice versa. So let me challenge you guys on your trig skills here. In Algebra 2 trig, and period 3 couldn't remember this, but can you guys tell me what trig function would you associate with x normally in trig? Which trig function is associated with x? So cosine, good. Do you guys remember what happened when you were studying the unit circle at first and the radius was 1? But when they started to give you guys problems where the radius wasn't equal to 1. So there was like a relationship between x, cosine, and the radius. Do you guys remember what that definition was? So this isn't new. It's like a trig thing that you guys learned. How is x, radius, cosine? Okay, so Tim actually solved it for what eventually is going to be how we'll memorize it. But do you guys remember when you were doing unit circle, and so most of you guys said x is cosine of theta, but that's assuming that the radius is equal to 1. So technically, if the radius isn't equal to 1, do you guys remember having this relationship? X over r is equal to cosine of theta. And if r was 1, like the unit circle, we'd have x over 1. And so you guys just translated that to x is cosine of theta. But technically, it's x divided by r is equal to cosine of theta. So Tim solved for it, times both sides by r. The relationship is if you are given polar coordinates, you can take r, times it by cosine of theta, and get the x equivalent on rectangular coordinate, in rectangular coordinate form. So what do you guys think y would be? Okay, so good. Just this is something that we have to know for the AP test. Okay, it's a step in a calculation for a derivative. So the sooner we memorize that, the better. And then when we get back from break, we're going to apply derivatives to things like this. Rectangular to polar might be a little bit easier for you guys to know. So if you guys were given x and y, how do you guys think x and y is related to r squared? You know, when you think of the general shape of most of even just our polar coordinate plane, how's r squared related to x squared and y squared? Good. You guys are thinking the equation of a circle, right? X squared plus y squared. So given x and y, we can find the radius by adding the square of both of those coordinate points. And then lastly, our tangent of theta, if we're given theta, we can figure out what, if we're given y and x, we can figure out what angle measure it yields for our polar coordinate system. What is tangent of theta equal to in terms of x and y? Property that you guys all should know. Correct. Okay, so none of this really should be new to you guys, but is essential for us to know for some of the problems, just the concepts behind some of the problems. You're not going to be asked to convert to rectangular coordinates or to polar coordinates, so this is just an exercise in review. So if I were given the coordinate points for 3 and 4, which are in polar, and asked to convert to rectangular, we're only going to do 3 because I don't think we need to do another one for this one. If I want rectangular coordinates, I'm going to use x equals r cosine of theta because I have r and I have theta and I want what x is. And same thing for y. I'm going to do r sine of theta. So plug everything in. You guys have x should be equal to r, which is 2 cosine of pi over 4. Just a note, you guys, on the series chapter test, it was better, but there were a few people who didn't evaluate unit circle. You have to evaluate your unit circle expressions on the AP test. So make sure that you guys somehow figure out how to memorize it or memorize it better, or figure out a system to get the correct values for these unit circle values. You know, I have you guys write a letter to your teachers, and one of the comments I've seen before in the past is and also letters to the future students, is that I wish I had memorized my unit circle better. And that is so important for some of these simplifications as we get into polar coordinates. But just simplifying this, we get rad2 comma rad2. That would be if I had a rectangular system superimposed upon a polar coordinate system. Rad2 comma rad2 would get me the same position as 2 comma pi over 4. Okay, that's all that means. Okay, so converting to polar coordinates, we're going to now work with the fact that r squared is equal to x squared plus y squared. So if I square x and I square y, I should get r squared equals 2, r is equal to radical 2. Okay, so what we're going to do is visualize for the angle measure. Sometimes it's easier for us to visualize where the coordinate point is in rectangular form to figure out what angle measure it is. You can most certainly do tangent of theta is equal to y over x. But keep in mind that you're not going to simplify the signs, because the signs are going to help you guys determine what angle measure we're talking about here. So I want you guys to picture where 1 comma or negative 1 comma 1 is. Okay, so it's here. What is the angle measure that would give you guys, tangent of what angle measure would get you guys that point in the second quadrant? So if we want to think about where x and y are equal, but the signs are putting us in the second quadrant. Very good, 3 pi over 4. So we want to pay attention to where that coordinate point is on the rectangular coordinate system to come up with the correct angle. So if I were to write this as r comma theta, it would be rad2 comma 3 pi over 4. Okay, let's do the last one as on 6 as 0 comma 2. If I were to figure out what the radius measure for this would be, I'm squaring both and I get r is equal to 2. 0, 2, what angle measure, if you guys were to picture where 0, 2 is, what's the angle measure that would get you guys 0, 2 on that particular axis? What angle measure would put you guys at 0, 2? Okay, so good, the angle measure pi over 2. And we're thinking beyond unit circle, this radius is not 1, but it's still, our angle measure is still pi over 2. So, okay guys, we're moving into our last examples here. On the next page, rather than converting rectangular to polar coordinates, now it's asking us to do a simple conversion between equations. So rather than coordinates, now this is equations. And again, not tested on the AP test, but useful to know Otherwise, just that there's a relationship between the two. Good practice. When you guys are looking at example number 7, there's 2 ways you guys can get, and oftentimes when you're going from polar to rectangular, you're trying to get r squared. So there's 2 ways you guys can make r squared. Okay, one of the ways is to times both sides by r. What's another way of getting r to be squared? Maybe this sounds like a really obvious question. Besides multiplying both sides by r, what else could you guys do? And it feels like it's the same question, but it's not. Yeah. Okay, squaring both sides and timesing it by r are 2 different things when we're talking about the option. So don't forget that that's an option, is that, you know, if timesing by r doesn't work, sometimes squaring both sides works. So here's what you guys want to ask yourself. If I square both sides, it's not going to give my right-hand side the r that I would need to change that to be a y coordinate. So what I'm going to do is give both sides an r, which means times both sides by r. And so in doing so, you guys have r squared equals, I'm going to move the r in between the 2 and the sign, 2r sine theta. And so now the r squared on this side is equivalent to x squared plus y squared. The r sine of theta on the right is equivalent to y, so 2y. Okay, so we can go further with this and figure out that, you know, do you guys remember and love completing the square and finding the equation of circles? We're not going to do that, but that's essentially what you guys probably did last year. But that is the equation of a circle. Okay, so same thing on example number 8. We have the choice of squaring both sides, or we can distribute an r. And so if I see cosine and sine without r's on the right, I'm probably going to want to multiply both sides by r to give each one of those terms an r. So multiplying both sides by r means to distribute r to each one of the terms. Whoops. Okay, converting everything to x squared plus, or x and y, so x squared plus y squared equals negative 3x plus y. Once again, the equation of a circle, if we completed the square on this and moved 3x and y over to the other side, we would get the equation of a circle not centered at 0, 0. In some ways, converting to polar might be easier because we know exactly, we don't have to like question what do we do to give something a extra r. And this on example 9 and 10, we're asked to convert to polar, and we know exactly what to replace x with and what to replace y with. So x is r cosine of theta, and y is r sine of theta. So doing that replacement, sometimes the problems do ask you guys to solve for r, in which case you, in this example, you guys have r in both expressions. So you can factor out your GCF of r, and then isolate by dividing both sides by that expression. So r is equal to 3 over cosine of theta minus 2 sine of theta. And 10, we see that's the equation of a circle, so it's easier to write that just like the first graph we graphed as just r squared. Or if we simplify that, the graph of a circle with a radius equal to 4. But no x's and y's left, everything in terms of r and or theta. When we get back from break, we're going to learn more about graphing polar curves when it's a little bit more complicated, like Rose curves, and we don't get